Hi guys, and welcome to determining whether a set of data represents direct variation, inverse variation, or neither. So you will have various tables here. So I have three tables here that we're going to look at. One of the big things is that we need to remember our equations. So the equation for direct variation, y equals some number times x. The equation for inverse variation, y equals some number divided by x. And remember, these can take slightly different forms, but for our purposes, especially here, all we really need is these forms, the general forms, because we're going to be plugging in numbers to see if it works. So you have a couple of options. Once you have a set of data, you can start by right away just plugging in those actual numbers. Okay, so we can start by right away just deciding, okay, I'm going to pretend like this is direct variation and start plugging in numbers. Or I'm going to pretend like this is inverse and start plugging in numbers and see if it works. No matter what method you choose, you're going to end up needing some guess and check, but it's good to have a little bit of a more informed estimate. So one thing that you want to think about is what are the possibilities. So for direct variation, the numbers are always going to do, x and y are always going to grow in the same direction, by which I mean if x is getting larger, then y will also be getting larger, okay? So you can see for this first one, that could possibly be direct variation. Here, while x is getting larger, the numbers for y are going down. So we already know that that's definitely not direct variation, okay? And then in number 3 here, the numbers are going up for x, and the numbers are also going up for y. So either 1 or 3 have the possibility of being direct variation, and then number 2 could be inverse variation, or it might be neither, all right? So you can't just determine whether it's direct or inverse depending on whether the values are going in the same direction or not. You have to also actually test them out. So that's what we're going to do. So for number 1, we're going to test it out. We know it's not inverse because the values are going in the same direction. So we're going to try out some of this direct variation. So all we're going to do is we're going to see if when we plug these points in, we get the same a, which would give us the same equation. Okay, so we're going to start with our first point here, which is 1, 3. So we plug in 3 for y. So we get 3 equals a, so some number times 1. Okay, so some number times 1 would be just a. So this would give us, right, 3 equals a. So for the first point, this point lies on a direct variation equation with an a of 3. So we now need to look and see, is this going to be true for the rest of them? Okay, so start with the next one. All right, so we've got y is 9. So 9 equals a times 3. Okay, and then we divide both sides by 3. And you end up with 3 equals a. So again, we get that a is the same thing. Okay, if we do this again for here, you would get 12 equals a times 4, divide both sides by 4, and you get that a equals 3, and then the same thing would happen right here. Okay, so we get the same a for every set of points, and so that means that it's direct variation. Okay, so this would be direct variation. Okay, so now let's move on to number 2. So for number 2, as x goes up, y is going down. So x is getting bigger and y is getting smaller. That means it can't be direct variation, so we're going to try inverse variation. All right, so we're going to try this and see if it works out. So for the first one, we plug these in. So 12 equals a divided by 1. You'd multiply both sides by 1, and you get that 12 equals a. All right, so we know for this first point that a is 12. So what we want is, in order for it to be inverse variation, the rest of these, when we put them in, have to also be 12. Okay, so let's try for number 2. So we would have 6 equals a divided by x, so that's 2. You multiply both sides by 2, and again, we're going to get that 12 equals a, and if you plug it in for the rest of them, you'll find the same thing, right? You would end up multiplying 4 times 3 and getting 12, and then 3 times 4 and also getting 12. So this one does indeed represent inverse variation. Now, the last one here is not going to represent either, okay? It could represent direct because the numbers as x is going up, y is also going up, but it actually doesn't. So when you plug it in, for the first one, you would get 1 equals 1a, so that would give you a equals 1. For the second one, when you plug it in, you end up with 4 equals 2a, and you would end up with a equals 2. And since those a's are not the same, this is neither. Okay, and that's it.